Seated by the window, gazing upon the nocturnal sky adorned with distant stars that twinkle amidst a majestic expanse, a sudden notion emerges in the mind. Why does an object traversing at the velocity of light appear to behave as though time itself has ceased? This is no fanciful reverie, but rather one of the profound enigmas of the cosmos, a subtle murmur of unseen forces that shape the entirety of our surroundings. Envision yourself aboard a spacecraft adrift in the boundless cosmic void. The hum of the engines resonates like the breath of a colossal, living entity, as you propel towards the utmost extremities, attaining the velocity of light and endeavoring to surpass it. Is such a feat achievable? What consequences might ensue from such an attempt? During our school years, educators instilled in us the notion that the velocity of light constitutes an absolute barrier, an invisible wall both firm and unyielding. Many accept this as an inherent truth of nature, yet few delve deeply into its underlying rationale. Beyond this threshold lie innumerable paradoxes that bewilder the intellect, akin to swirling vortices in the obscurity of space. Is it truly an invisible barrier that impedes us? Or, as we advance, do unknown forces repel us with ferocity, like unseen hands emerging from the shadows? The reality we shall explore is far more intricate than the visions of imagination, and it unveils the mysterious portals of existence. According to the theory of special relativity, promulgated by Albert Einstein in 1905, and here we extend our sincere gratitude to Albert Einstein for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. When the velocity of an object approaches that of light, the temporal dilation effect escalates to extreme proportions. Time no longer flows at its accustomed cadence, it decelerates infinitely and nearly solidifies. For the object in motion at that velocity, time seems utterly arrested, ensnared in an eternal instant within the flux of the universe. To grasp this, we must commence from the very essence of the velocity of light. We humans inhabit a realm constrained by automobiles and aeroplanes, thus light appears to us as a transcendent entity, surpassing the boundaries of our senses with an unimaginable swiftness. Light in a vacuum traverses precisely 299,792,458 meters per second, a figure of dizzying magnitude. Nevertheless, on the immense scale of the universe, this velocity resembles that of a snail creeping languidly across an infinite desert. In the present day, humanity is ardently engaged in space exploration, aspiring to distant planets, forsaking the solar system to wander amongst galaxies. Probes are dispatched, rockets launched, and interstellar voyages conceived. Yet those distances, those infinite expanses, bind us to this diminutive solar system like chains of iron. In everyday life, light is so rapid that we perceive no motion, it illuminates the world in an instant. However, confronting the boundless immensity of the universe, light almost forfeits its significance, diminishing to an isolated whisper amid the roar of a tempest. Consider the sun as an exemplar, the star at the heart of our system, the fount of light and life. Solar light requires 8 minutes and 20 seconds to reach Earth. Should the sun abruptly extinguish and vanish, we would persist in its luminescence for another 8 minutes and 20 seconds before darkness descends. This is a harrowing delay, compelling us to realize that the universe is not an instantaneous domain. To Neptune, light covers approximately 4.5 billion kilometers in over 4 hours, and we remain within our familiar solar system. Gazing further, towards other stars in our galaxy, the issue amplifies. The light from those stars arrives after tens, hundreds, even tens of thousands of years. Thus, when we admire the constellations in the nocturnal sky, we observe the past, events from remote epochs, perhaps predating the birth of our ancestors. Directing our gaze into deep space, we journey even further back in time, as through a lens of light-permitting temporal voyage. Since we cannot exceed the velocity of light, reaching the edge of our galaxy would demand millions of years, an odyssey spanning generations. Traveling to other galaxies then seems inconceivable, an endeavor so protracted as to feel like a curse, tethering us eternally to this minuscule corner of the universe. The barrier of the velocity of light constrains us to Earth like invisible threads, rendering dreams of conquering the stars distant and melancholic. Resolving this riddle could transform everything, not merely for a deeper comprehension of the universe, but for unlocking interstellar voyages, attaining alien worlds, and sensing the breath of extraterrestrial life forms. Nonetheless, to truly comprehend why the velocity of light holds such singularity, we must rewind the annals of time and return to the pioneers who first unveiled this secret. The narrative commences in 1676, at the Royal Observatory in Paris. There resided the Danish astronomer, aged 32, Ole Rømer. Picture him as a patient sentinel of the universe, seated nightly at the telescope, scrutinizing the dark heavens with curiosity and resolve. He was tracking Io, the swiftest moon of Jupiter. His primary duty was to calculate Io's orbital period to aid navigators in orienting amidst oceanic waves and stars. Yet, during repeated observations, he discerned an anomalous phenomenon, like a secret whispered by the universe into his ear. When Earth receded from Jupiter, the observation time of Io lagged behind predictions. Conversely, when Earth approached, the time advanced. This discrepancy amounted to mere seconds, but it was consistent, like the pulse of a concealed heart. In that era, most astronomers believed Io's orbit unstable, but Rømer differed. With bold intuition, he pondered, perhaps light requires time to traverse space. At the time, it was held that all in the universe occurred instantaneously, with the sky as a stage where light never delayed. Rømer's idea was akin to an earthquake-shattering worldly comprehension. He recognized that, when Earth was distant from Jupiter, light must cover a greater distance, causing the delay. Employing the rudimentary instruments of the age and estimates of Earth's orbit, he computed the velocity of light at approximately 220,000 kilometers per second. It was a monumental leap, humanity's first acknowledgement that light is not instantaneous, but flows through infinite space like a river with its own rhythm. Rømer must have felt touched by the soul of the universe, igniting an eternal curiosity in subsequent generations. We extend our sincere gratitude to Ole Rømer for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. 2 centuries later, in 1849, the French physicist, aged 29, Hippolyte Fizeau resolved to measure the velocity of light directly upon Earth. Envision him as an audacious explorer, dissatisfied with remote observations, determined to seize the secret with his own hands. His method was simple yet ingenious, a delicate dance between technology and intellect. He established an apparatus between 2 locales, a potent light source, a rapidly rotating toothed wheel with precise gaps, and a large mirror 8 kilometers distant. The principle resembled a pursuit game. Light emanates from the source, passes through a wheel gap, journeys to the distant mirror, reflects, and returns, seeking to pass through the gap anew. If the wheel rotates sufficiently swiftly, the teeth obstruct the returning light after the 16-kilometer round trip. By precisely adjusting the rotational velocity, Fizeau identified the exact point where the light vanished and calculated the travel duration. The outcome was 313,000 kilometers per second, remarkably close to the modern value. It was an epochal triumph, demonstrating that light is not an abstract concept, but a measurable, tangible phenomenon. Fizeau must have experienced the joy of an artist completing a masterpiece, knowing his experiment would pave the way for greater discoveries. We extend our sincere gratitude to Hippolyte Fizeau for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. In the ensuing decades, further experiments shook the world of physics with even greater violence. In 1887, at Cleveland, Albert Michelson and Edward Morley conducted an experiment destined to enter the annals of history. At the time, it was believed that light propagated like sound or waves through a medium, an invisible substance termed ether, that permeated the universe and was deemed absolutely stationary. Light moved through the ether as a fish through water. According to this logic, since Earth orbits the Sun at 30 kilometers per second, the velocity of light should vary depending on the direction of Earth's motion, faster with the wind and slower against it. Michelson devised an extraordinarily sensitive interferometer which split a light beam into 2 perpendicular directions, recombined it, and detected velocity differences. If the ether existed, travel times in diverse directions would differ, yielding a clear interference pattern with a shift of about 0.4 fringes. But when the experiment commenced, nothing occurred, no shift, no alteration. They rotated the apparatus 90 degrees, yet still zero. They repeated it across seasons, with identical results. In every direction, the velocity of light was the same. It was incomprehensible, like swimming in a swift current and measuring identical speeds everywhere. The physics world was upended, and this failure ignited a revolution. We extend our sincere gratitude to Albert Michelson and Edward Morley for their extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. While physicists grappled with the enigma of the velocity of light, in a modest patent office in Bern, Switzerland, a 26-year-old youth with disheveled hair and an enigmatic smile scribbled notes. It was Albert Einstein, the man fated to alter the course of science. Einstein proposed a staggering idea: light does not conform to our motion, rather, space and time bend before the constant light. This led to the theory of special relativity, one of the grand discoveries of modern physics. It all began with a simple yet profound query: how to synchronize clocks in a railway system. How to verify distant events. This thought drew him deeper, prompting, what if we pursued a beam of light? According to Newton's classical physics, we would perceive light as a stationary wave. But James Clerk Maxwell's electromagnetic equations rendered a stationary electromagnetic wave absurd. It was a fundamental contradiction. Einstein, with audacity, changed history. Instead of amending Maxwell, he questioned space and time. He presented two revolutionary postulates. The first: the laws of physics are identical in all inertial reference frames, no frame is privileged, none can claim absolute rest. The second: the velocity of light in vacuum is constant for all observers, irrespective of their motion. This seemed mad. How can light travel at the same velocity for everyone? It contradicts daily intuition. If a train travels at 100 km per hour and you hurl a ball forward at 50 km per hour, to a platform observer it is 150 km per hour. But if you ignite a torch, the light proceeds at 299,792,458 meters per second for you and the platform observer, unchanged. How? The answer lies in a sly trick of space-time. To maintain light's constant velocity, time dilates and space contracts. The universe adapts to preserve coherence, like notes in a harmonious symphony. We extend our sincere gratitude to Albert Einstein for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. We once conceived time and space as absolute and immutable, like solid pillars. Instead, they are pliable, interwoven, and alter according to motion. This is Einstein's revolution of space-time. Newton's static stage transforms into a living dancer, with time and space curving and stretching per objects. All adjusts to the dance of motion. But why is the velocity of light precisely 299,792,458 meters per second? It is no arbitrary numeral, it is a fundamental property of space-time, rooted in the essence of being. This velocity dictates the causal structure of the universe, how causes link to effects, how information disseminates, how the universe remains logically interconnected. Without this limit, causality would collapse, effects might precede causes, rendering the universe chaotic, a muddled dream where past, present, and future intermingle. This limit is no capricious rule, but the key sustaining cosmic order, the heartbeat synchronizing existence. For instance, if the sun vanished, we would learn only after 8 minutes and 20 seconds, as information cannot travel faster than light. Meanwhile, Earth would orbit a vanished sun in a final waltz before obscurity. In truth, in a certain sense, we all move at the velocity of light, an idea that may astonish. From birth, we traverse space-time at that velocity. If this velocity defines information propagation and causality, what meaning does it bestow upon our existence? We are composed of information, parts of a vast causal chain. To understand, we must shift perspective on space-time, not separate, but unified, a space-time with 3 spatial dimensions and 1 temporal. Imagine it as a map. We move north-south or east-west, but on the same plane. In space-time, we shift more in space or time, but the total velocity is light, constant. Each instant, we traverse space-time at that velocity. We merely distribute it between space and time. When stationary, we devote all to time, passing through it at light's velocity. Walking, we allocate a small portion to space, and time slows slightly. Driving at 130 kilometers per hour, we dedicate more to space, and time slows further. On a spacecraft near light's velocity, most goes to space, and to an external observer your time dilates. This is temporal dilation. It is no mysterious effect, but a velocity distribution. Even if you deem yourself still, from birth you move at light's velocity in space-time. You are space-time explorers, ceaseless cosmic voyagers. Conversely, photons, light's particles, devote all their velocity to space, advancing at 299,792,458 meters per second, but for them time halts. A photon reaching your eye from a distant star after billions of years has not aged. You and the photon share the same total velocity, but distributed differently. This explains why absolute stasis is impossible. It would equate to vanishing, freezing eternally and severing from existence. In space-time, continuous motion is essential for being and evolving. Your destiny is bound to proceeding at light's velocity, as if the universe invites you to an eternal dance. Next time you gaze at the sky, remember you observe not from a fixed point. You are on your flying vessel, traversing space-time. Without halt, without return, the universe propels you onward. Yet in this destiny lies freedom, choosing direction, focusing on time or space. The velocity of light is no barrier, but existence's essence, a significant stride towards the future. Now let us broaden our gaze to modern theories, where scientists persist in delving into this secret. The eminent astrophysicist Neil deGrasse Tyson emphasizes that the velocity of light is the velocity of causality. Surpassing it would dismantle universal order. How would you measure something faster than light, when the measuring instrument relies upon it, he queries. In discussions of 2025, he has reiterated that the velocity of light preserves the logical continuity of the universe, and he has elucidated how cosmic expansion permits distant galaxies to recede faster than light without violating relativity, as space itself stretches, carrying galaxies along without local motion exceeding the limit. We extend our sincere gratitude to Neil deGrasse Tyson for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. The string theory specialist Brian Greene posits that, within string theory encompassing 10 or 11 higher dimensions, space-time might fold to enable effective movement swifter than light without locally surpassing the velocity. He describes wormholes as tunnels slicing space-time, linking distant points like bridges, traversable instantaneously, yet necessitating negative energy for stability, which remains enigmatic. In 2025 researches, new approaches to negative energy have been proposed, including models of low-energy density wormholes that could exist on macroscopic scales without immense masses, and studies on ghost wormholes that naturally violate null energy conditions. Greene also explores how quantum entanglement and wormholes may be facets of the same underlying reality, bridging quantum mechanics and gravity, as evidenced in recent papers suggesting entanglement creates wormhole-like connections in holographic dualities. We extend our sincere gratitude to Brian Greene for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. The theoretical physicist Michio Kaku invokes Miguel Alcubierre's 1994 warp drive concept, which contracts spacetime ahead of the vessel and expands it behind, permitting faster-than-light voyages without locally breaching the limit. Kaku cautions that, though compliant with theory, it demands energy equivalent to Jupiter's mass, and misuse could engender temporal paradoxes. In 2025, Novel warp drive models have emerged, including those eschewing negative energy, with segmented designs rendering hypervelocity travel nearer to engineering reality, as detailed in articles on Warp Factory and a Strum drive, employing numerical tools to model warp drives' unique physics, such as subliminal constant velocity drives that adhere to known energy conditions and could propel vessels at speeds approaching light without exotic matter. We extend our sincere gratitude to Michio Kaku for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. Recent experiments of 2025 have further validated relativity. Physicists at the Technical University of Vienna and the University of Vienna have visualized objects moving at 99.9% of light's velocity appearing rotated rather than flattened, confirming Roger Penrose's 1959 prediction of the Tell-Penrose effect. An illusion revealing how reality distorts unexpectedly, achieved through ultra-fast laser pulses and gated cameras capturing snapshots of cubes and spheres in simulated relativistic motion. We extend our sincere gratitude to the physicists at the Technical University of Vienna and the University of Vienna for their extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. Prior to his passing, Stephen Hawking warned that surpassing light's velocity might enable time travel, yet raises the grandfather paradox: if you returned and slew your grandfather, you would not exist to perform the deed. Tyson adds that hypothetical particles like tachyons might exist, but would fracture causality, rendering the universe chaotic. In 2025, tachyon researches, reconciliations with special relativity have been proposed, suggesting tachyons need not violate fundamental principles, though causality issues persist. Studies from universities such as Warsaw and Oxford offer fresh perspectives, including models of tachyonic dark matter traveling faster than light, potentially explaining cosmic anomalies without disrupting local causality. We extend our sincere gratitude to Stephen Hawking for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. Alan Gough's eternal inflation theory suggests our universe is a bubble in an infinite multiverse ocean, where each bubble might possess a distinct light velocity. But in ours, it is constant, like an immutable vow. In 2025, Gough has discussed infinite phase space and the two-headed arrow of time, applying particle physics ideas to the primordial universe, exploring how eternal inflation generates diverse vacuum states leading to multiversal diversity. We extend our sincere gratitude to Alan Gough for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. Roger Penrose's conformal cyclic cosmology proposes the universe recurs in periodic cycles, with infinite expansion phases becoming new beginnings, not a singular Big Bang but an eternal chain. In 2025, our 14 papers, new concepts on natural transitions dominated by gravitational waves have been introduced, and proposals on higher spin fields that might play a role in conformal cyclic cosmology, clarifying how crossovers between eons occur naturally, perhaps through conformal rescaling that links the remote future of one eon to the Big Bang of the next. This evokes wonder: we in a cycle, with past and future entwined? From Hawking to Green, these inferences strike the enigma, making us perceive the universe not as a cold machine, but as a living entity brimming with mysteries awaiting discovery. We extend our sincere gratitude to Roger Penrose for his extraordinary contributions, for the silent sacrifices, and for the unwavering dedication to human knowledge. Through all this, the velocity of light is no mere numeral, it is the key to comprehending ourselves, the essence of the journey in space-time. It awakens profound emotions, the yearning to transcend bounds, humility before the boundless universe, hope to one day dance with light and uncover new horizons. Now you comprehend, and perhaps you will gaze at the sky with altered eyes, filled with curiosity and mystery.